I'm Linda Lara, and I want to welcome you to the Aspen Institute series, Conversations with Great Leaders, in memory of Preston Robert Tisch. For those of you who are joining us for the first time, I'd also like to welcome you to Roosevelt House, the Public Policy Institute of Hunter College, and the historic home of Sarah, Franklin, and Eleanor Roosevelt. And for the past 14 years of this program, Roosevelt House has also been this program's home, thanks to a wonderful relationship that we have had with Hunter College and my wonderful colleagues at Roosevelt House. The Conversation with Great Leaders series began in 2009, thanks to a generous grant from Lori Tisch and her brothers, and over the years has featured leaders who are making a difference in their communities by the way they look at their role in helping to build and maintain a civil society. By civil society, I mean one that ensures fair and equitable treatment for all individuals. These leaders represent the values and commitment to public good that reflects the work of the man honored by this series, Preston Robert Tisch. Before I go further, can I encourage you guys to come in, and we've already begun the program? Thank you. Okay, tonight is very special for me. As those of you who attended public school in New York City will know, no school year was complete without a class trip to the American Museum of Natural History. Whether your preference was for the huge dinosaur looming over the entrance, or the lifelike exhibits of ancient societies, or dioramas of animals in their habitats, there was always something memorable about a visit to the Museum of Natural History. I'm happy to be able to tell you that the museum and its newly opened Gilder Center for Science, Education, and Innovation are as exciting as ever. As my sister exclaimed during our recent visit, the dinosaurs are even more scary. And the new exhibits, from free-flying butterflies to insects hard at work, with a terrifying list of all the creepy crawlies that exist in this city. They are sure to enthrall generations of school children. So I'm excited that tonight's speaker, Sean Decatur, is going to talk about his new role as the leader of the American Museum of Natural History. The former president of Kenyon College, Dr. Decatur's academic credentials include Dean of the College of Arts and Sciences at Oberlin College, where he was a professor of chemistry and biochemistry, as well as teaching at Mount Holyoke College and as a visiting scientist at MIT. He has also won research grants from the National Science Foundation, National Institutes of Health, as well as a number of private foundations. He is a fellow of the American Association for the Advancement of Science and a member of the American Academy of Arts and Sciences. Dr. Decatur has a PhD in biophysical chemistry from Stanford University. Tonight's moderator, Aaron Mertz, earned his bachelor's degree in physics from Washington University in St. Louis, master's in the history of science from the University of Oxford as a Rhodes Scholar, and doctorate in physics from Yale University. He then was a National Science Foundation postdoctoral fellow in biology at Rockefeller University here in New York City. 4.5 years ago, he made the move from the research lab to the nonprofit sector to become the founding director of the Aspen Institute Science and Society program, which, across a wide range of formats and outputs, catalyzes community leaders, current and future scientists, and the general public to build a better scientific ecosystem, society, and world. And now I'd like to turn the program over to my colleague, Aaron Mertz.
Thank you, Linda. Back in April, I received an email from the president and CEO of the Aspen Institute, Dan Porterfield, saying that he had recently connected with a biophysical chemist turned president of Kenyon College, who was just named the president of the American Museum of Natural History here in New York, and that we should connect. So happily, I took a city bike ride from my apartment where I live and work in Midtown to the Upper West Side, met Sean. We clicked really well and outlined some ways that our different organizations could work together to further science's role in our society. Then this summer, Linda reached out to me to say that she was hoping her next event on leadership as part of the New York Public Programs could be about science, and did I have any ideas of whom we could present about science? And I thought immediately Sean would be a great person. And then Linda said, well, how about you moderate it? And so here we are tonight, and really grateful for this invitation. And I'm thrilled to see many familiar faces and also some unfamiliar faces tonight. I hope to meet you afterward. And I'd like to acknowledge some of my colleagues who have joined me from afar. We are a fully remote program, but in town from Tennessee, Jelana Sheets is my program's associate director. Hassan Farah is in charge of our social justice initiatives, and Sejal Gaud is our communications coordinator. So welcome you to New York. One thing my Science and Society program colleagues and I work on a lot at the Aspen Institute is initiatives to attract younger people to the field of science. And one initiative we have in that field is called Discover Discovery, and it's a platform in which we publicize scientists' discovery stories. So not what they're actively discovering today in the lab, but when they discovered that science is a beautiful field in itself and could be the fuel for a full career. And I posed this question initially to my advisory council back in 2020 when the program was just me. And instead of going around the Zoom room, because it was the height of COVID, I asked them, instead of saying their biographies and their resumes, to let me know when they discovered science. And the stories were beautiful. They were almost all about childhood teachers, family relatives, nature walks. And I thought there is a lot of merit to people hearing these stories. It could attract younger people to find great merit in those stories early on as a possible source for fuel for a career one day in science. And it could also inspire current scientists to think of a new way to talk about their work publicly. And so, Sean, I would like to ask you, and I will say, I hope you will participate in this project, Discover Discovery soon. What is your discovery story about science?
Well, thank you, Aaron, for that question, and thank you for the invitation to join you in conversation here tonight. I was reflecting on this and think the moment that comes to mind is when I was an undergraduate working in a research lab for the first time, and the very first time that I saw a phenomenon that no one else had seen before. At least I think that no one else had seen before, partially because it's a little bit obscure. So I think maybe there's someone in the world who is interested in this one obscure thing, but I suspect I was the first person to see this. And to go down the rabbit hole a little bit, I was a student who originally started college as an engineer, eventually decided I was going to do pre-med and go to medical school. I found out that I passed out at the sight of blood. Pre-med was probably not for me. And I had a chemistry professor who encouraged me to pursue research and introduced me to a research project. My sophomore view of what research meant, and if people asked me as a sophomore what I was doing, I would say that I am trying to cure cancer because we were studying a selection of molecules that turned out to be useful as reagents binding to DNA and potential cancer drugs. I was pretty convinced as a sophomore that I was going to cure cancer. Maybe before my senior year, that would probably make a good senior thesis topic.
Good to be ambitious.
Exactly. But it turned out what I ended up working on was taking these molecules called porphyrins, and particularly water-soluble porphyrins, and encapsulating them in little vesicles that were made up of phospholipid bilayers. So they're sort of like little artificial cells that we were capturing these molecules in. And it turns out that this one particular molecule, when you captured it inside these little artificial cells, would totally change its chemical properties and would change color. That was the thing that was most striking, but we could correlate that color change to a change in the way those molecules were interacting with each other. And when I first did this, I was convinced that I had just done something wrong and showed it to my advisor, who then and I just remember this very clearly, he looked at the spectrograph, kind of put it down, and then held out his hand to shake my hand and said that, this is like you've just discovered a new phenomenon. You've just discovered a new thing. And it was the coolest thing ever. And I just sort of wanted to have that day over and over again forever as working in lab. And I still look back on that notion of what that feeling is when you see something that's totally brand new, that's incredibly exciting.
Love that. I'll share briefly my discovery story. I don't think I've ever even shared this with my teammates. It happened a little earlier. It happened in my first physics class in high school when we did a unit on sound waves. And I went home and found all of the harmonics and overtones that we had talked about were recapitulated on my cello. And all the equations were correct. And I thought, wow, here is a beautiful discipline that can explain things that I take for granted as beautiful, inherently beautiful, but explain them elegantly and quantitatively. And that's what hooked me on the field of physics my junior year of high school. So it happened a little earlier. Yes. And I'm always struck by people who have significant careers in science research and then transition to educational or societal work. And that was my path, and I'm happy to talk more about that, but I want to hear about your journey. What prompted you to shift from the research lab to education, more broadly speaking, many years ago?
Yes. Well, I loved, from that moment as a sophomore in college, I loved doing research. But then I also loved the environment in which I was doing research, and I just developed a deep admiration for my advisor and the mentors I had that were helping me along the scientific discovery and journey pathway. So when I went to graduate school, pretty convinced that I was going to go to a small liberal arts college and start a research program and mentor a bunch of undergraduates. And I actually remember my first meeting of my PhD advisor, who then was asking me, so why are you in graduate school? And I said, well, it's because I want to go back and go to a liberal arts college and mentor a bunch of undergraduate students. Very quickly said that, why would you want to do that? Was unsure whether that was the right pathway. And I think it was many years later, I think, that we were talking after I'd become president of Kenyon College. He said, well, that liberal arts college thing really worked out for you in the end as a good move to do. But that combination of research and discovery, but helping other people sort of realize both the wonder of research, but also to develop their skill set to understand how to think scientifically, to solve scientific problems, is something that was interesting to me. So I got my PhD. I got a job at a small liberal arts college. I built a research program, was working with undergraduate students, and realized that I was also interested in how to help my colleagues develop those skills and develop their research programs, and that the level of impact one could have in not only working on an individual lab, but helping a department of labs kind of do this work was important. And that just sort of began my movement of beginning to think not only in terms of an individual lab, but a collection of labs. And then it was a small step there from a collection of labs to an institution, and another step to thinking about that to a college. But for me, what are the ways in which we can build systems that help people learn and develop, yet also learn and develop while generating new knowledge is something that was important. To me, that's fundamental what a college is about, is a place where people learn and develop, but also are committed to the discovery and dissemination and discussion about new knowledge and new information. And then, the cool leap is to be able to do that, to go to a museum, which is fundamentally the same thing, but at a scale that, 6 months ago would have been completely mind-boggling to think about still is a little bit mind-boggling to think about in terms of 5 million visitors a year and a deep impact on education from pre-K through postdoctoral fellow that happens at the museum. But the core, how do you take scientific discovery and make it accessible and available to people so that they learn and also kind of get captured into that wonder while you're actually doing new things and discovering new things is still kind of at the core of what drew me in.
You've beautifully explained how that transition in your mindset happened gradually in these different roles you had. How could science education be different today to impart that mindset in younger scientists so they don't have to go through a long career to learn those things, but to understand science's role in our society early on?
One thing that I think is often missing in science education, it's actually something that's it's not a particularly strong point of our education system in general, is making the link between the work of a scientist and leadership. That it wasn't until I was leading my own lab that I realized that I would need leadership skills, which was probably then a little bit too late when you're sort of all of a sudden in charge of a bunch of folks that you need to bring together to work together as a team to collectively solve a problem.
It's not taught earlier in graduate school.
Exactly. I think it's one of those things that you learn a bit in an apprentice model in graduate school, but the notion,
by osmosis.
yes, but that notion that all of the things that go into leadership, which actually a lot of which is, how do you bring a disparate group of people together and have them work with a common goal in mind and do that effectively and efficiently, yet also maintain that, that little bit of chaos, which is helpful for the creativity and to bring in a diverse range of viewpoints that's helpful for moving things forward. I've just discovered over time that leadership is about helping and supporting and empowering other people. And I sort of learned that by being tossed into, here's a research lab, go build it and get a group of people to move forward. Finding ways to make that a little bit clearer in the education process, I think it's helpful both in terms of developing the skill sets of our next generation of scientists. I also think it'll be helpful for drawing people into what science is about, because I hear from many people who still have this image that science is something that you do all alone in a corner somewhere, and you occasionally go out and talk about your results. Instead of thinking of science as probably one of the more dynamic team-oriented fields that I can imagine, that every moment of working in science has been sort of working in a team and learning how to work in a team. I think that could actually also draw in folks who sometimes are turned off by this image of science being a lone genius kind of work, as opposed to science being an effort in understanding people and the relationships of people is the core of what science is about. I think the more we could bring that into the education process, the more that may also make science more accessible.
Mm-hmm. Love that. And it echoes a lot of what we think about with an initiative my program has called Our Future is Science. And its principal pillar is a mentorship program where we match high schoolers with STEM graduate students to explore how science can be used to make their communities better, healthier, stronger. And it's all about intersections between science and social justice, showing how science is applicable to people's everyday lives. And we're really thinking about in our program, beyond the Discover Discovery initiative, how we can excite younger generations to go into the field and stay there and have careers hopefully like yours one day.
Yeah. Well, and I think that connection between the importance of mentorship, which is a theme that certainly has run through my career, and something that's been important once I sort of flipped to the other side and was able to mentor others. That's been important. And then to help institutions like AMNH, where there are programs for mentoring high school students who come and work in our research labs, as well as college students and graduate students in our own graduate program. Mentorship is a key piece of what it takes to help folks move along the pathway of becoming a scientist. But I also think that hook of understanding how the core science, fundamental science, is connected to bigger problems and issues is important as well. So I was joking that as a sophomore, I was absolutely convinced that I was working on something that was going to cure cancer. that actually was also the hook that got me interested. I think if my professor had just said, you're going to work on the aggregation properties of water-soluble porphyrins when they're encapsulated in small spaces, I think my sophomore self would have glazed over and would not have followed that path, right? But the piece which kind of caught my interest and led me in was the notion of why would you do this? Why are those molecular properties important? And then understanding that those molecular properties are important because they simulate a type of behavior that DNA shows, which is really going to be critical for understanding how this disease works. That caught my interest. And so I was doing something very narrow, but developed an understanding of how that narrow thing fit into a bigger picture and a bigger landscape. And I think as we work with young people, we need to make sure that they develop the skill sets and the understanding of the specific problems that they're working on, but we also need to make sure we're linking those problems to broader issues that will capture their attention and to make sure that they're always able to answer the why they're doing the work that they're doing.
Yep. Love that. And on the leadership question, you talked about what you learned about leadership in the lab because it was not taught to you earlier. How did your views or impressions of leadership change as you stepped into the broader academic administration and now you're leading a whole big museum?
And I do think, it's interesting. I often think that leadership would be easier if people were molecules. Molecules actually, they follow rules. Sometimes we don't know the rules molecules follow, but you can always sort of elucidate kind of what molecular behavior is like. I think anyone in this room who has led a group of people know that, if people are molecules, they're certainly nonlinear behaving, very dynamic, complicated molecules that we are trying to then work with and shape. That sense of the importance of the skills of listening, observing, being able to realize that there are moments where empowering others is way more important than actually sort of proving or demonstrating your own authority on something. Those are skills which I've sort of learned by trial and error, I think, over time. But I found that the same things that could help to bring a research lab together to organize and solve a problem could be effective in bringing a leadership team together at a college when you're trying to figure out how to transition a residential college to remote work during COVID, right? That it's fundamentally that same thing of how do you listen, how do you empower, how do you kind of help to maintain clarity when there's chaos going around, translates on different scales, and that's an important thing, at least I've learned from leadership.
Mm-hmm. The theme of this event tonight is the story of us. How is AMNH telling the story of humankind?
And I think the museum tells sort of stories that are fundamental to understanding what it means to be human on a range of different levels. I often reduce the core of the museum's science, both the science that is done sort of in discovery at the museum, but then the science that we try to disseminate and educate, explain to the broader world, as really being about people and planet. So we're interested in understanding the fundamental nature and history of the planet, of its inhabitants, of the people on the planet, how actually people and animals and plants have helped to shape the planet's development over time, how the planet has in turn actually shaped the behavior of people and cultures and animals and plants over time. And that stretches in everything from understanding the origins of the universe to the origins of life on the planet to the comparative development of human culture in a broader global context. And one of the things that I think is important about that is to make sure that we can show the links and connections. So why is it important to understand geology as well as to understand human culture, and how are those things connected? As well as to be able to relate that to some of this kind of goes back to the why, to the pressing issues and problems of the moment. And so if we think about things like climate change, we can understand climate change in terms of what the geophysics and climate scientists, atmospheric science tells us about what's happening on the planet. We can tell the story of climate change in terms of how it's impacting life and how we can track that through the collection in terms of changes in living things across the planet. We can understand climate change in terms of its impact on human cultures and how human cultures have responded to changing environmental conditions over various points in time. And to me, the magic happens when you begin to draw the dots, link the dots to connect those stories. So you can understand how, our scientists who've done expeditions in one particular area where what the anthropologists have learned are connected to what the geologists have learned, which are connected to what the biologists have learned, because we can understand the inner links between physical science and biological science and social science and human studies of human culture.
A big part of the museum is collections, and I think collections can take on multiple purposes. They can be a repository for conservation or preservation. They can be used as research materials for research to examine, and they can also be used in exhibitions for the public to see. How do you think about collections as we approach the conclusion of the first quarter of the century?
Yeah. Well, and it's one of the things I think that visitors to the museum might actually miss about the larger context of the American Museum of Natural History is that we are a place with a collection of nearly 35 million specimens and objects, only a tiny fraction of which are on display and exhibition at any moment. So one question that comes up, so as I was conveying that fact to family and friends after sort of letting them know I was coming to AMNH, some of my family who are more blunt than others who would be more less blunt, would say, why do you need 35 million things? And maybe the corollary, I would say in excitement that, we have 35 million things, including 3.5 million fish. And, the question that follows then is that, why do you need 3.5 million fish? And is that enough? When do you stop collecting fish? And the answer is, well, you never stop collecting fish. So why? What's the value of having a collection of that magnitude? And today, I think in the current context, our collection is more important than ever, and we have new ways of looking at and thinking of the collection. So if we really think of our collection as telling the story of the history of life on the planet, that means that we can find things now. If we imagine that we've had scientists who've been going to the same islands in the South Pacific to observe and collect birds for 150 years, going back to the exact same site. So we have then specimens which track a particular geography of 150 years of development and evolution of particular birds. We know which birds have gone extinct, which birds are now more rare. We can use modern techniques, though. We can use contemporary molecular biology techniques to now go back in time and to collect genomic information across 150 years of birds in a very particular area. We can do imaging to get to detailed structural morphology data about the specimens over time that we couldn't do before. We can do chemical analysis to actually know differences in what the birds may have been eating 10 years ago versus what they're eating now. How does that correlate to changes in ocean temperature, which might be changing food availability? All of these things, if we think of the pressing need to be able to demonstrate how the world is changing around us, our collection tells that story, and we now have new technological tools to be able to reach back in time and to get detailed information about changes in life on the planet, which means that the more the collection grows and the more we can understand changes that have happened on the planet, the more we can begin to really pinpoint in molecular detail how those changes occur, and to begin to think about not only what the impacts of climate change are, but what are strategies for mitigating and responding to climate change over time. So it's an exciting, incredibly exciting time. And just as one other cool thing that's on my mind, just because I am fresh from this, I think I mentioned earlier, we've just had a 2-day conference on new technology, new discoveries in dinosaur science at the museum. So we've had room of a couple hundred dinosaur paleontologists talking about new discoveries. And they're talking a lot about the fact that we can get ancient DNA now from dinosaur fossils, and to get information about mapping out the tree of life with dinosaurs in a lot of detail using DNA data. We can also image things that we haven't been able to image before. So there are old fossils in the museum that people had just assumed were the leftover rocks that were around, that were kind of picked up when the big bones were brought there. We can now image those things that were considered leftover rocks and find details of fossil skeletons of very tiny animals that were there that we couldn't see before. So these are things that have been in the museum for decades that now we can see new detail. And that new detail is exciting, partially because the big dinosaurs all died, right? The things that survived were actually the small things, so we are related to the small things that survived the extinction, not as directly to the big things that went extinct. So as we begin to image those and extract out, develop tools to extract out detailed molecular information from those fossils, we can begin tracing our own biological history back to the days of the dinosaurs, which is incredibly cool. Again, those are things that can only happen because, the prescience of a century ago, someone decided that, there are these things here, but I'm actually just going to take these other rocks as well, even though they look like they're not terribly interesting. Maybe one day someone will figure out kind of what's in these rocks. And we're reaching that point where the technology is allowing us to do that.
Is there a particular collection that you're potentially more excited about as a scientist than other people who might be viewing it as a non-scientist?
Yeah, and that's a little bit, that's really close to, sort of your favorite child question. That is a little risky to say, though. One of the things that, as I've learned more, that is really interesting to me is, our meteorite collection. And some of this is, and I know I'm in conversation with a physicist who certainly will have opinions on this as well. But as we learn more, and again, as our tools for understanding chemical composition improve, we can begin to extract data on the sort of really trace amounts of elemental material that's in meteorites, which tell us important things about the chemical signatures that were happening on the other side of the galaxy, right? So why is that important? Well, it's important as we, both from a fundamental astrophysics perspective, right, of understanding how did the universe form. But it's also interesting when we begin to think about questions of, well, where did the types of molecules that are responsible for life form, and how did they form, right? And so the more we can know about trace amounts of elemental material that you can get, that you can extract off of meteorites, the more that it's beginning to give us a comprehensive history, not only of the universe, but of the connections of life to the universe.
I'm smiling a lot when you say that because it takes me back 20 years to when I was an undergraduate and actually was a researcher in a lab about pre-solar grains. So these were pieces of meteorites that were not from our solar system, but actually were from supernovae or other stellar events that occurred before our solar system was even born, 4.6 billion years ago. And we could isolate those portions of meteorites and then learn insights into how nucleosynthesis, the formation of elements, of isotopes based on what's happening inside stars, happened. So I haven't thought about this in many years, and I'm thrilled to hear meteorites come up tonight. That's really exciting to me. Let's see. I've read a lot about museums' struggles collecting and returning objects to certain cultures. Most of us probably think of these issues facing art museums, but could you talk about any examples about this issue with returning collections that you've dealt with at AMNH?
And certainly one of the areas that is, an area of struggle not only for AMNH, but I think the natural history museum community in general, involves cultural material that's collected, sometimes from archaeological digs, sometimes from directly from expeditions that were sent to engage with cultures, in North America, around the world, that brought material back to the museum and the museum's culture that has sacred, important cultural meaning to the groups from which the items were taken and then brought, separated from those groups and brought to the museum. Particularly an issue with cultural groups indigenous to North America, where the relationships between the expeditions that were going out, often associated with perhaps military campaigns or other movement of peoples in North America, were taking material that might have been funerary material taken from grave sites, might have been things taken by force from cultures and brought into the museum. There's a set of regulations, the North American Grave Protection Repatriation Act, called NAGPRA within the museum insider community, which was passed over 30 years ago, about in the early 1990s, which gives a framework for institutions to return materials to recognized Native American tribes federally recognized within the U.S. Through a framework and a process. Over that time, AMNH has returned, well over 1,000 specimens and objects, and this is a process that is important to realize that it is. I was talking to a reporter from Science a little while ago and explaining that this doesn't mean that you sort of put the material in a box and you put it in the mail. This is really about developing close relationships between the museum and indigenous communities across the country. It has to be relationships that are grounded in a sense of trust, because trust both in the confidence that the museum has in the groups that we're working with, but more importantly, I think confidence that those groups have that the museum is acting in good faith to transfer and return material. And I think a sense of trust that can lead to healing and reconciliation between the museum and those communities, that this isn't really just about returning the objects, but it's about repairing the past whenever possible. And so, it's a process that's very important to us, and it's one that certainly we see not only continuing but accelerating over time.
You and the museum have received a lot of press recently for a new initiative to handle human remains differently, especially in exhibitions. Could you say a little bit about that new initiative?
Sure. So, the part of the collection that had been built up in the museum over time has included human remains. So these could be materials that were unearthed in archaeological expeditions. These could be materials that were brought to the museum from medical schools, for bodies that were used for anatomical demonstration or research that were transferred to the museum. It also, there are a number of examples of I think, even less savory skeletons being brought to the museum, for example, that were unearthed in public works projects in the city. And in the early 20th century, it was practiced that if a skeleton was unearthed in digging a road or a subway line, to call the museum, and things were brought to the museum. Through all of these, the museum has a collection of about 12,000 individuals. And we're taking steps both to make sure that we understand our collection, the individuals that are present at the museum, where they came from, sort of what the origins were. These are from around the world, to make sure that we are doing all we can to steward appropriately the storage while we investigate how individuals can be returned to descendant communities. And also, I think, importantly, take the steps of removing individuals from display. I think it had been the practice of the museum of some time to put human remains on display. This is typically not in something that's terribly scientifically informative. It's more along the lines of, here is a result of a dig, here's some pottery, here's some bones next to the pottery, not something that is telling an important, scientifically important story, but something that is truly dehumanizing in terms of putting the remains of an individual just sort of on an equivalent level of other material that's found at the site and not recognizing that, those are people. That's important to acknowledge. And so, we're taking the step now to remove those items from display as we do work to identify descendant communities and make sure that we can do all that we can to return appropriately the individuals that we do have. At the same time, we're very much interested in making sure that we develop education materials to tell the story of both these individuals, how they came to the museum, and what this says about the history of institutions like ours more effectively.
One of the topics that my program works on a lot is trust in science. I have my own hypotheses I could share about why there are some people who don't trust the endeavor of science. What are your hypotheses, and what could possibly address them?
Yeah. I think from my view, a lot of the distrust of science arises from the sense of science, the scientific process being opaque and sort of behind closed doors. Scientists are often not as forthcoming and dynamic as they could be in explaining the full picture of the scientific work that happens. I think that labs can be intimidating places and aren't necessarily inviting places for people to come in and see. And the complexity behind scientific decision-making often gets skewed, maybe not by scientists themselves as they communicate, but certainly by the way scientific discovery often gets translated into the popular media in declarative terms which sometimes obscure not only the uncertainty but some of the reality of what the science is. It's interesting. This happens a lot in the medical and health literature. One of my favorite social media sites, back when I used to use what was formerly known as Twitter, was a Twitter site that was a bot that would automatically take announcements about scientific discoveries that were medical announcements and just kind of insert above them in mice. So there would be something like, new discovery on low-fat food, results in rapid weight loss, and it would just take the same thing and just put above it in mice, because almost all of these discoveries are things that happen in lab animals, but the translation of that into people gets obscured in the way it gets presented in the popular press. That disjunction between how something gets described in the popular press and what the actual science is leads people to hear and set a level of expectations that when it's disappointing, really does lead to that sense of distrust. And so the more we can do to be clear and transparent about how science works, to sort of explain what the difference is between a model laboratory study and something which has demonstrated impact on human populations, to invite in people to understand the nature of the discovery process, the more I think we can begin to take apart that things that lead to distrust.
I'm nodding a lot because that's exactly my hypothesis and my program's hypothesis. And we're working on a film right now, a documentary feature-length film that will illuminate the lives of scientists at the early stages of their careers, and all of the professional trials and tribulations that go into those careers that most of the public has no idea about. Most people don't know that scientists have to struggle to get research grants, submit papers for publication, get them rejected, buy equipment, build a research team of graduate students and postdocs. Most people have no idea how that works. And so we're going to tell stories like that from a few early career scientists in very humanizing and entertaining ways to shed some light on the scientific process. So that's also my hypothesis, is that the process is very opaque.
Yes.
And I think at this point, we have about 13 minutes left. I would love to facilitate some questions from the audience. We have one mic runner, and we'd prefer you to use the microphone because we are videotaping this discussion. I see a hand already in the back. A little farther back in the corner. Yeah.
I was wondering what the museum could do to make it more economically friendly to the average New Yorker. For example, and correct me if I'm wrong, you don't participate in Museum Mile, you don't participate in the Free Fridays, you're not like the Met where a New York resident either pay as you wish or free. Have you all thought of any programs to make it more economically accessible to the over 25-year-old?
Yeah. And actually, the museum does participate in Pay What You Wish to not only New York City residents, but any residents of the tri-state region, so New York, New Jersey, Connecticut. And so and that is as small of a donation as folks want to make. When you come to the museum, you can use Pay What You Wish either when you buy in advance on your mobile device or when you come to the museum. You just need to show some sort of proof of city residency or tri-state region residency. And so we participate in that. I'd say we also, in terms of general access and commitment to bringing folks in the museum, there are a few other programs which are very important to me and I know very important to the institution. One is the school group program to bring in folks who come in on field trips, and those are field trips which are subsidized, and so the students are able to experience the museum. Many of our education programs, which are aimed at supporting science education opportunities of New York City school children, especially our participation in the Urban Advantage program, which is in middle schools and elementary schools throughout the city, serves thousands of students each year. That program not only gives students an opportunity to come to the museum, but we felt that it's always very important to extend that to families as well, because part of the learning process happens not just of the student coming to the museum, but the student being able to bring family members, caregivers to the museum as well. And so that sort of broader constellation, sort of a sample of the broader constellation of programs to really make sure that the city is broadly accessible. And I think that as we move forward, that notion that the museum really has to be open, and that sense of belonging and connection of every New Yorker, sort of seeing the museum as their museum, is something that's important to us.
Next, please.
Hello, I'm Clint Brownfield. I'm a travel writer based here in New York City on the next block. This isn't a question, it's a compliment, and a thank you. I went to a press preview last Friday morning at the New York Historical Society. I took the bus across 79th, walked in front of the museum, and I stood there and stared. There were people all over the world patiently waiting to get into the museum, 10:30, basic Friday. Your next blockbuster has not opened. I'm going back in a week or so for The Secret Life of Elephants. You know how sneaky elephants are. There were people wrapped around both blocks, down to 77th, almost over to Columbus Avenue, up to 81st, almost to Columbus Avenue. I'm on the press list of every museum in the city. I've never seen anything like that. I'm sure the new wing has been publicized. These weren't school kids. They go in another way. These were with people, maybe with an occasional child, waiting to get in. So keep up the good work.
Thank you. Thanks. And it's really heartening to see, and not just heartening as the museum president to see this, but I think when we think about public spaces that truly bring in a global cross-section of people, and from countries around the world, from various backgrounds here in the U.S., from various age groups, there are not many places that sort of are open, accessible places that generate that sort of common ground for coming together of such a diverse range of folks. And so one of the things that's interesting to me is how do we make sure not only do we maintain that, because I do think it's important to maintain the status of that trusted common ground that brings together diverse ranges of people, but how do we leverage that, right? In a world where institutions are being distrusted at an astounding rate. How do we maintain that sense that the museum is a place where everyone can find something that brings them in, and that we can sort of unlock a sense of education and learning of the folks who do come in?
Over here on the left, my left.
Hey, Eric Gross. I work for the Aspen Institute's Citizenship and American Identity program. This is going to sound like a statement, but I promise it will turn into a question.
Kenyon College graduate, I'm sure it will turn into a question.
Yeah, also Kenyon College, class 2018. Very excited to be here. Long-time listener, first-time caller. So I essentially disagree with both of your assessments on distrust in science, although I appreciate you being so self-reflective about scientists' role. I just essentially think that people are so polarized and so partisan that they care more about advancing their own ideas than they do in discovering truth. My question is, do you think that the Natural History Museum has a role in countering hyperpolarization? Because I don't want to assume that you do. And if so, how do you see that role?
No, and what's interesting, there was a survey done by the, let's always forget whether it's American Alliance of Museums or Alliance of American Museums, but the AAM, that a few years ago that actually identified, museums are one of the last few trusted public institutions out there. And then there's been a lot of sort of questioning of, so why? So what is it about museums that do that? I think that natural history museums in particular remain fairly trusted in terms of the types of information they convey and provide. My own hypothesis around that, and this maybe connects into where I do think we can play a role in maybe bridging some of the hyperpolarization that's out there, is that there's some fundamental wonder about nature that supersedes or it's deeper than the hyperpolarization, right? That the brown bear in North American mammals is just jaw-dropping in terms of wonder about the world around us, right? And that I think is a shared experience across across political and social polarization. And I had a little bit of an experience of that sort of reflecting on my previous job at Kenyon, where, in trying to think of how we bridge the college community and the local community, which had tinges certainly of that political and social polarization, there were some things about the natural world that folks could come together and appreciate. Now, when you jump straight away to talking about political agendas that are directly connected to those, you begin to fray that a little bit. But if you start the conversation at why we actually value clean water and clean air and good quality open space, you could bring people together and then sort of move the conversation gradually from there. And I think that's something that museums can do by finding that the common ground is often in that wonder about nature, and that I think has the potential to bring people together to transcend the polarization. How you get the conversation going to move forward beyond that is the place where I think there's work for us to do. But I think that's actually, former college president, I'm like an optimist. I think there's actual real potential in the museum's ability to facilitate those conversations that I'm not sure that other institutions can.
Yes, in the back. She'll bring the microphone over.
What learnings are there from the Gilder Center in terms of its structure and utilization that you envision applying to other of the older exhibits?
And there are a few things that come to mind, that I think we've already learned from the first 5+ months of the Gilder Center being open. One is the power of having exhibition, education, and research so closely intertwined within the same building. That building is one of the few spaces, in a very public way, that you can see and engage with, sort of standard exhibition. There are classroom spaces there, there are research spaces there, and the fluidity between them has already paid off in a few ways. So, for example, we have a program that we're running this fall of elementary school groups that are in residency for long periods of time at the museum. So it's not a one-off field trip. You can spend a few days or even a week at the museum teaching classes at the classrooms in the Gilder Center. Those classrooms then are able to go literally outside the door of the classroom to an exhibit and then back in, right? So you kind of get that adjacency, which is powerful. And on the way, they can see scientists at work on the other side of the glass that's right outside the classroom, and sort of reinforce that science isn't this thing that is sort of dead and static. It's a thing that's active, going on. And to be able to capitalize on those adjacencies, I think, is very powerful. And that's one thing. A different type of integration, though, that we're also learning, and I should do the advertisement. Please come to the Gilder Center if you haven't come. So it is really amazing and very cool to see. But the new exhibitions in the Gilder Center, I think, do a great job of integrating classic specimens. So the insectarium is a great example where you can look at a whole bunch of pinned beetles on a table, but also with interesting interactives that help to enhance the information that comes from that. And that, recognizing that many, not just our young people, but many of us now actually do respond to learning in different ways, to be able to flip between not just seeing things on screen and interacting things digitally, but also not just looking at things in a pinned specimen table, but to be able to go between them, and the synergy that happens, the connections that get made in the brain when you are learning in those different ways, I think, is also powerful. And as we begin to take a look at some of our older exhibition spaces, that's where I've been asked the question many times. It's one of those loaded questions because I think everyone knows the answer. Like, you aren't going to take down the Hall of African Mammals, are you? And it's sort of I'm not crazy. So yes, I'm not coming into the institution where the dioramas that everyone loves will remain the dioramas that everyone loves. But how can we complement those with types of experiences like we're learning in the insectarium, which can take some of the powerful learning you get from observing specimens and connect that to digital information, which actually helps to complement and enhance. And so I think within the Gilder Center, we're getting a deeper understanding of how that relationship works.
Take one more. Here in the middle, in the pink. One second. Here it comes.
Hi, I'm Carol. I'm just still disappointed when I walk by to see that Teddy Roosevelt on his horse isn't there anymore. To me, it still indicated, signified his visionary experience and his expeditions, his willingness to appreciate the natural habitat and America's beauty and that of the other continents. Anyway, be that as it may, what are you putting up there? I may have missed it. What's next?
Right now there's no immediate plan for another statue that's there. There is, in fact, there's a plaque there that does recognize that this is that wing of the museum is the Roosevelt Memorial. There is still the beloved statue of Teddy Roosevelt sitting on a bench that's inside the Roosevelt Memorial, and this really terrific exhibitions that are in that space that not only recognize President Roosevelt's contributions to the broader national landscape of conservation and understanding our natural history within the country, but down to the level of what did the young 13-year-old Teddy contribute to the Natural History Museum in its early days in terms of his pinned collection of bugs and other items that he found in the backyard that ended up in the museum's collection and are still in the museum's collection or on display in the Roosevelt Memorial. So, that connection to the importance of Teddy Roosevelt and his father, who was one of the founders of the museum, to the broader understanding of the importance of conservation, but the importance of what natural history museums could be is something that's very much honored. As I think folks know, the statue, which was removed before I arrived at the museum, but the statue, the key issue wasn't Teddy Roosevelt, but the attendant figures that were there, and a sense of many people who, while in a sense the pride that sort of wells up in seeing the strong presidential figure there, also could lead to a sense of shame or anger with the figures that were not depicted with a sense of kind of overall human dignity in the way that they were in the statue. And so, the balance of wanting to make sure that everyone feels that not only the museum but the city is can be reflected in its art and in its symbolism with that sense of pride and not with the sense of lack of dignity is something that that I think that many people felt was important to do. And so I think that was a decision that I think was a good decision to make, yet at the same time, the honoring of President Roosevelt within the Roosevelt Memorial and the Roosevelt Rotunda is something that we've certainly kept going, and to, in fact, make that clearer in terms of the contributions to the nation and the museum.
We are out of time, so thank you so much for coming. If you are a scientist of any sort, of any age, please share your story with us at discoverdiscovery.com. It's just a 30-second video that you can upload. And for everyone else, including the scientists, please go to the new Gilder Center and AM&H new Elephant Show opening soon. Thank you,
Secret
Sean.
World of
And thank
Elephants.
you all for coming.
Okay.